So for this video, we're looking at the second fundamental theorem of calculus. Now the first fundamental theorem said that if you took a definite integral from a to b of an f prime of x dx, then you would get f of b minus f of a, the net change in your antiderivative. This one says if f is continuous on an open interval containing a, so a is some x value, then a is some number in an interval, then for every x in the interval, the derivative of the integral, so you are undoing things, of some function of t dt equals f of x. And that should make sense from what we did over here. We took the derivative of an integral, and to do that we did the antiderivative, we plugged in our x, evaluated at x, and then we took the derivative. So we're saying that we're going to have a variable swap. So the derivative of the integral, they undo each other, but our t's have been replaced by x's once we've actually evaluated. So if you could ask a question like this, find the derivative of the integral from 10 to x of sine of t dt, then from the second fundamental, we know that that is just going to equal sine squared x. Now that seems like it should be too simple, but you're taking the derivative of an integral. Now when we evaluated the integral, when we plugged in the 10, we actually got a number, and then when you take the derivative of the number, that gives you 0. So you really are just doing a variable swap, but only if it asks for the derivative of an integral. So if you look at another example, it says find f prime of x, big F prime of x, and we know f of x equals the integral of the square root of 2t squared plus 3 dt. Well, it's saying to take the derivative of this integral. If you're doing the derivative of the integral, you're going to get something that looks just like your starting function, but we have the variable swap from when we evaluated at x. So this will very simply equal the square root of 2x squared plus 3. And again, you're doing the derivative of the integral, so you should get something that looks like it's in the same format, but when you do the antiderivative, you plug in x. Now, this is an interesting problem because you actually could not do the antiderivative by hand, and if you ask the calculator to do it, it might give you back the same exact thing. This looks like it should be u substitution. U would be 2t squared plus 3, but your du would be a 4t dt, and you don't have a 4t sitting on the outside. In fact, you don't have a t on the outside. So this lets the AP test and other people actually ask you to do definite integrals that you cannot find the antiderivative for. So that happens in two occasions. One, where you're actually expected to pick up the calculator and plug in, because your calculator can always do definite integrals because it's estimating area, or if it's asking for the derivative of the integral, and then you can actually just write down the answer.